The everyday chemical mistake we still repeat. It feels harmless. Routine. Something humans have done for decades without a second thought. But chemically, it was always a gamble. Most people believe mistakes in chemistry happen in laboratories. Explosions, spills, miscalculations. In reality, the most dangerous chemical errors are woven into daily life, repeated millions of times a day, quietly shaping long-term consequences we barely notice. To understand why this matters now, we need to look at how chemistry interacts with habit. Reactions do not care about intention. They respond only to conditions. Temperature, concentration, timing. When those variables are pushed repeatedly in the wrong direction, chemistry keeps score. At first, the mistakes seemed efficient. It saved time, reduced cost, simplified processes. The reaction still worked, so no one questioned it. Results appeared normal. Products functioned. Life continued uninterrupted. But chemistry does not judge success by appearance. It judges by balance. Each repetition nudged reactions slightly off course. Bonds formed where they shouldn't. Byproducts accumulated unnoticed. Systems designed for occasional exposure were forced into constant contact. This is where the story begins, with a choice that felt small, even sensible, but introduced a chemical pattern that never truly stabilized. A pattern that modern life continues to reinforce, despite mounting evidence that the reaction was never meant to run this way. As the habit spread, chemistry adapted in predictable ways. Reactions designed for short contact times were forced to persist. Catalysts exhausted faster. Protective barriers weakened. What once reset naturally now remained under constant chemical pressure. Because the effects were slow, they blended into the background of normal life. Materials aged faster than expected. Surfaces degraded. Air and water carried traces of reactions meant to stay contained. None of it triggered alarms. It simply became familiar. Scientists studying these patterns noticed something troubling. The chemistry itself wasn't flawed. It was being used outside its intended rhythm. Like a reaction held at the wrong temperature for too long, the system didn't fail immediately. It drifted. This is where early conflict formed. Industries optimized for convenience resisted change. Consumers preferred speed over chemistry. The mistake wasn't dramatic enough to demand attention, yet it was widespread enough to matter deeply. Attempts to correct it met resistance. Alternatives required patience, different conditions, slight inconvenience. Chemically safer options existed, but habit proved more powerful than understanding. Over time, the accumulated byproducts began interacting with systems they were never meant to reach. Indoor environments changed first, then external ecosystems followed. Chemistry crossed boundaries simply because repetition made it inevitable. The mistake persisted not because it was unknown, but because it was comfortable. And chemistry, unlike humans, does not forgive comfort when balance is ignored. The conflict deepened as evidence became harder to dismiss. What once appeared harmless now revealed patterns too consistent to ignore. Chemical markers showed up where they shouldn't. Reactions overlapped, interfering with processes never designed to coexist. The problem was scale. One exposure meant nothing. Millions meant transformation. Chemistry amplified repetition into consequence. By the time effects were measurable, the mistake had already reshaped systems at their core. Researchers traced the issue back to a simple mismatch. Chemistry built for occasional use had been turned into a constant. Reactions that needed recovery time were denied it. Stabilizing agents broke down faster. Protective reactions failed to keep up. This created a cascading effect. As safeguards weakened, chemistry grew more aggressive. Substances interacted more freely. Secondary reactions emerged, producing compounds with behaviors no one had tested for long-term exposure. The emotional tension peaked here, not because the mistake was catastrophic, but because it was preventable. The science was clear. The chemistry was understood, yet behavior remained unchanged. Industries hesitated to redesign systems. Consumers resisted altering routines. The reaction continued, not because it was necessary, but because stopping it required effort. Chemistry had done its part. It delivered clear signals. The conflict now lived entirely in human choice, whether to accept short-term convenience or to interrupt a reaction that had already been running for far too long. The climax arrived when the cost of repetition finally became visible, not as a single event, but as a pattern repeating everywhere at once. What made this realization powerful was its simplicity. The chemistry never changed, only the way it was used. A reaction designed for one context had been forced into another, and chemistry responded exactly as expected. This moment shifted perspective. The mistake was no longer abstract. It was measurable, traceable, correctable, but only if habits changed. Chemistry cannot adjust itself back to balance without cooperation. The resolution is not dramatic. It is practical. Slight changes in timing, reduced exposure, better alignment between chemistry and context. Small adjustments, repeated consistently, allow reactions to recover their intended behavior. This story reminds us that chemistry is not distant science. It lives in routines, in products, in daily decisions that quietly shape long-term outcomes. Understanding this turns responsibility into empowerment. Progress does not always require invention. Sometimes it requires stopping a reaction we never meant to start in the first place. And sometimes, the simplest correction has the greatest impact. Subscribe to join the journey.